بسم الله الرحمن الرحيم. أعزائي طلبة المرحلة الثالثة في قسم الفيزياء كلية العلوم الجامعة المستنصرية، السلام عليكم ورحمة الله وبركاته. In this video I'm going to talk about voltage regulation. It is well known that the electric damages occurring in the electric devices are principally due to change in the voltage of the sources. So when the input voltage of a power supply increases to a higher value, the output circuit becomes in danger and might be damaged. Therefore, regulators are usually used as a protector that prevent such damages in the devices. Regulators are the final step of power supply. Here we see two types of regulators, Zener diode and IC circuit. Now study the Zener diode. The Zener diode is a p-n junction diode operates in the breakdown region. That means it works in the reverse bias region. The current can flow through the Zener diode when the applied voltage reaches a certain value called Zener voltage or breakdown voltage. This voltage is dependent on the amount of the doping. In other words, the Zener diode voltage becomes low when the diode is highly doped. As seen in this figure, this is the typical electronic circuit of Zener diode. The diode is connected in parallel with the power supply. The cathode is connected to the positive terminal and the anode is connected to the negative terminal of the power supply. IV characteristics of Zener diode. We have already known that the Zener diode should be connected in the reverse bias configuration. That means the cathode should be connected to the positive terminal of unregulated power supply. The typical behavior of IV characteristic of Zener diode is shown in this figure. There are two different regions, forward region and reverse region. The forward region is very similar to a p-n junction diode behavior, while the reverse region is different from a p-n junction diode behavior because the current can flow through the Zener diode when the applied voltage reaches V sub Z, breakdown voltage. This point is referred to as knee. Okay, right now we can say a reverse current passes through the Zener diode, but there is an essential question. Why this current doesn't damage the Zener diode? The answer is because the current is limited between two values. Maximum value, which is denoted by IZ maximum, and minimum value, which is denoted by IZ minimum. When the current is out of this range, of course the Zener diode will be damaged. The equivalent circuit of Zener diode is shown in this figure. We have two cases. The first one, if the output is bigger than V sub Z, then the diode works as a closed switch to allow the current to flow through it to reduce the IL as well as V sub L. That means V sub L is equal to V sub Z and the IL is the difference between I out and I sub Z. This is the first case. The second case is inverted. While the V out is less than V sub Z, then the Zener looks like an open switch. That means IZ is 0 and V out here is equal to V sub Z and I out is equal to I sub L. Positive voltage regulator. Nowadays, there are many types of IC chip can be used as regulators. The family is referred to by 7800. 78, this prefix means positive regulator, and the number after 78 refers to the voltage. For example, 7805, that means the output will be 5 volt, and 7812, that the output will be 12 volt. This This type is shown in the figure below. Here we see the IC has three leads: input, ground, and output. And the electronic circuit of this IC is shown here. The VN is connected to the output of the power supply, and the Vout can be taken for the output voltage. In this example, the input voltage is 220 volt and the Zener voltage is 50 volt. The requirements are the output voltage, the voltage drop across the series resistance, with and without the Zener, the current passes through the Zener diode. The first one, when the Zener is connected, that means the output should be the V sub Z. So VL is equal to V sub Z, and this is equal to 50 volt. The second, without the Zener, VL is calculated from the voltage divider because V sub Z is 0. So VL is equal to this ratio RL over RL plus R sub L times the input voltage V, which leads to V sub L is equal to 146.6 volt. VR is the difference between VL and V input, so this is equal to 73.4 volt. Now, when the Zener diode is connected, that means the output should be 5 volt, and the drop voltage on the series resistance R is the difference between the output and VZ. So it is equal to 170 volt. The current passed through R is equal to V sub R on R, and this is equal to 34 milliampere. So we have I and I sub L. I sub Z is equal the difference between I and I sub L, which is equal 29 milliampere.